Hello friends, this is Praveen. Welcome to the third part of the chapter Light. If you have not watched the part first and second, I recommend you to watch it first. So let's get started with our today's part. So today first we are going to cover about the lenses. What are the lenses? Have you ever tried to play with a convex lens? What you do is from the sunlight you focus all the rays on a paper, and without moving your hand for some time you see that there is a fire on the paper. So how that this work, and how what are the different types of the convex mirror, what are the different types of lenses are there, what are the different types of the images formed by these, and how these lenses work, we are going to learn. So what actually is a lens? A lens is a transparent object material which is usually made up of the glass or plastic bounded by one surface, and one surface is flat. So what happens? So what is a mirror? Mirror is usually transparent or object which is usually made up of the glass or plastic. It may contain the one straight surface, both one straight surface or one curved surface, or both the curved surfaces, like that way. So how we can form a lens? So the lens is formed with the use of the two spherical mirrors. So use of the two spherical circles, spheres, from which lenses are obtained. From where these have a two distance between the two spheres, we formed a concave lens, and when there is no difference, they are obtained like that way. This is called the convex. There are not only for two mirrors lenses, but there are many types of. So the main examples of these are: first, this is convex. So this is convex, this is concave. This contains both the spherical sides, and what if the both sides were, it was sometimes we see like that way mirrors, like shape of the moon. These are the convevo convex, or the convexo concave. So this is convevo convex, and this is convexo concave. And we have learned that one side could be also sphere, from which we see there are two types more. So this type of mirror lenses is called plano convex and plano concave. So how does these lenses are formed? So we are going to see how these lenses are formed. So in the reflection, we have learnt about when a light enters from, just like there is a glass here. When a light enters from the rarer medium to denser medium, or the denser medium to rarer medium, it bends. But when this is entering at a perpendicular distance, it would move in a straight line. So what we can do is to create such figures from which light coming would converge. So what we can do, place a somewhat uh, like that way figure. So it is here it is longer, and here is it smaller, and same structure like that way. And at the finally we create a dome like structure on the top, dome like structure. So what would happen if the light would come due to the when we'll see, due to the refraction, it would bend. And when the light would come here, the it has the more distance, from it is traveling the less in the slow speed, so it would bend more. And the same with the upper cases, and we will make the light converge here. So what if we bring all that? We got a convex mirror. The convex mirror is also known as the converging lenses. This is a convex lens, and it is also known as a converging lens. And same, if we make it divert, so we take a small piece of glass and create a sections here. Create a sections and a small section here. So what would happen here? The light would come, it is perpendicular, it would go straight. Here the light would come, it would bend more, and it would bend slightly, and just like these are bending, not inward. So they are bending, and this would go straight, and this is bent. So these types of mirrors are these types of lenses are called concave lenses. A concave lenses where the focus is in the center, so it is diverging the rays, so these are also known as the divergent mirror or the diverging mirror. So let's learn the few terms about the related to lenses. So first, there is a lens, and we draw a line which is passing through its center, and its center is called the referred as O, where O stands for the optic center. It What is an optic center? It is the center of the lens. A light of a ray passing through it or through the optic center does not undergo any divergent. So it could not either converge or either not diverge. So this line on which it is there is called the principal axis. So this is called P. Here we have P stands for principal axis. So what is the principal axis? A horizontal line passing through the optic center. This is the optic center passing through the optic center of the lens is called the principal axis. So this is the principal axis, this whole line which is passing through the optic center. Then we have it's called the principal focus. So how we can define the principal focus? So imagine a parallel beam of lights are coming. Parallel to what? Parallel to the principal axis. They all meet. They all meet. Where these all meet are called the principal focus. This is called PC, and where PC is referred as principal focus. So this is principal focus. So what happens in a concave lens? These the parallel beam of the light would come, but it would diverge, not converge. So we know that principal focus is formed when the two light rays converge. So but these are diverging. So where is its focus? So what would the observer think when he sees a diverging beam of rays? He would see that the all the light would be coming from this point, which is a straight line. So he does not think that why will he think that the light is bending? He thinks that the light is coming straight, so it would be moving, coming from that direction. So where it is coming is also called the principal focus, which is PC. And the length between the focus and this focus and this optic center is called the focal length. And we have also learned from which these mirror lenses are cut. The center of these is known as the 2f, that the length, this is f, and this the center of the sphericals is the 2f. Why they are 2f? Because its length is twice of that. So the length is twice, so the focal length would be also twice. If the focal length is x, so the distance between the 2f and the o would be the 2x, and if it is a x. So these are the terms. Now how images are formed in a convex and the concave lenses we are going to learn about. So how these images are formed? So we have see how the images are formed in the convex and the concave mirrors. These lenses are opposite of the convex mirrors. So here are lenses and here are mirrors. So convex and concave, convex and concave. The image formed by the convex mirror is similar to the image formed by the concave mirror, and the image formed by the concave mirror is similar to the convex mirror. These are reversed. For the both cases, they are vice versa. So let's see how by a practical method how these images are formed. So when first take a case when the image object is placed object is at infinity. So the object is at infinity. So this is our convex mirror. So first we are talking about the convex lenses. So this is the principal line. This is the F, optic center, F, 2F and 2F. So when the object is at infinity, the parallel beam of light would come. So parallel to the principal axis, the light would come, and so what would happen? It would we know when the light would come, it would meet at the focus, and this line would also meet at a focus. So this is meeting at the focus. So the we know that the image is formed when the two beam of light meets. So it is the image is formed here. So what type of image is formed? It is the we are not imagining it to be formed, but that it is a really forming, and it is inverted in size. When it is real, it is inverted in size, and it is very smaller, just like a point size. That is also smaller than the object. So it is also smaller than the object, as you can see how the image. Now let's take the second scenario where the object is at beyond 2f. So here it is a finite distance but beyond the 2f. So this is the mirror lens, optic center, f, f, 2f and 2f. So here is the beyond 2f. So let's for simplicity we will take only the two rays of line, because that's enough to make our image. So parallel one, let's take a parallel, and one that is going in any direction. You can take passing through the optic center. That's the sin. So without passing through the optic center, it would go undiverted, and from here it would pass through the pass through focus. So when it would pass through focus, it would meet between the 2f and f. So this is the object here. So what are the characteristics of the object? The characteristics of the object as again real and inverted, and it is smaller in size compared to the object. Now take the third scenario, in which, so this is our third scenario in which we are going to take the image placed at a fixed at 2f. So first we have tried about the infinity, then 2f, then beyond 2f, then we are talking about the f, then we will take f, then f, and between optic center and f we will take. So when the image is at up to that 2f, how the images is formed? When the image would one line would go straight and meet at the focus, and one line would go to the optic center. So these all would divert, and these all would formed in this case would be formed at the 2 fixed at the 2f. So this all would be formed at the 2f. So what now what are the characteristics? You can see they are same in size, approx same in size. So this is object form is same size, image formed is same size of object, and it is again real and inverted. So when the image is real, it would be always an inverted. Let's take the fourth scenario, in which the light, now we have taken it the object to be on 2f. Now between f and 2f, so this is our lens, f, 2f, f, 2f, optic center. So it is here. a line would go, and it would pass through that optic center. It would pass through the focus, and when a line passing through the optic center would go undiverted, so it would form the beyond the 2f. So what are the characteristics? It is as you can see, this is smaller and this is larger, so the image formed here is larger in size, and also it is real and inverted, real and inverted. So now take the fourth scenario, we will take at the 2f. So at the f, so this is the optic center, this is f and this is 2f. This is we know this is f and this is 2f. So this is the object, here would be placed our objects here. So when the object is placed here, one we will take the parallel beam of light and one passing through the optic center. So when would this be? So as you can see, this would pass for here, and this is pass to the optic, pass to the focus and go. So we know they are converging, they would converge, but we can't see its end. So we know that by the fact that they are converging, so they would meet anytime in light, so they would form at infinity. The image is at the infinity, and we can see that they would form, they are not diverging, so means always a real and inverted image is formed when two diverging two converging rays meet, so it is inverted. And the image is then we will see that the distance from the principal line is more, so the much larger, so the more the distance, the more the image, so it would be the much larger image would be formed, much larger image it would be formed than the object. Now see the, let's take the scenario sixth, in which the this is the object is placed at the f. So between the f and the optical center, the image is formed, placed here, and this is f and this is 2f. So when an image, the line would go and the one parallel line would go, it would move here, and this would go here and move. So you can see that now the rays of the light are diverging. So diverging means they will never form. So when they will never form, our image would be the, so what will the observer think from when he is seeing the diverging rays coming? He would think that these rays would be coming from here. So it would coming from here, and the image is formed at the same side of the object. And what is the nature of the object? So we are thinking it to be formed, so it is a virtual and erect images are formed when it is placed between the f and the 2f, and the image is of course larger in size. So convex lenses only form the virtual and erect images when it is only placed between the f, so it is between the f and the optic center. So now let's see the image formed by the concave lens. Concave lens. So it is a concave lenses. So we know that the convex mirror is similar to the concave convex 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 lens is similar to the concave mirror, and the concave mirror is similar to the convex lens. So the properties exerted by the concave lens would be similar to the convex lenses. So there would be only how we place the image. We know that image would be always virtual and direct. So let's try out. So we would take the scenario when the, so let's see that image. We take any scenario. Let's place our, this would be f and this would be 2f. Let's place the light at any source, so it is formed. Let's place it here. So what would happen? A line would go and diverge. a line would go to pass and diverge. So we know that a convex mirror diverges the lens, diverges the light, and the diverged light always forms the virtual and erect images. So in any case, the lens would form the virtual. In any when the object is placed at any point, the image would be always the virtual, and when the object is virtual, it is erect, and the object is then we can see is much more larger, so it is larger in size. We all have seen rainbows, and why there are different types of colors in the rainbow. Have you ever wondered the different colors in the rainbow, how these different colors are even formed? So this is not necessary even when you see a rainbow. This is always formed sometimes when you are taking a shower, and even forms near the when you have washed the dishes. So how these rainbows are formed? Let's see. It's science. So to perform this, we have to take let's conduct first an experiment. In this experiment, we will take sunlight. So this is our sun here, and from which we are taking a one sun ray coming. So to this you can place a cardboard, and from which there is a tiny opening only, and you place a prism. So what is a prism? A prism is a triangular structure made from the triangles, and it is made up of the glass. So and you can take a screen. So what would happen if a light would come? It would passing all the light passing through it would go, and there would a magical process happen in the prism, and when you will see that a rainbow is formed. So how this actually rainbow is formed, we are going to see. So what happens in a prism, the prism simply acts like a droplet. So this is a droplet and this is a prism, as you can see. So um, due to the we see due to the refraction, so when the light is coming, due to the refraction, it would bending to the moving to the denser medium, it would bend. But sometimes what happens, it would bend and move away, and it would move bend again. Why it is not passing, we will see that later. And when this would come, the speed of the light is slowing. So the light is converged. Light is made up of the several colors, and when the light comes out from this, the light is being expressed. So what would happen? The ray would come from here, and the opening would create a rainbow. So why the first we will see why this the light is do not reflected from come out from here. It is a not a opaque object. So why this is possible? This is possible due to the critical angle of the reflection, in which the when you take a to perform this, you can perform an activity, take a water, and so what you do is if the light is coming 90-degree, we know that it would go straight back upside in the water also, or it would come down without any angle difference. So but what would happen if we make a light go in such an angle, so that if we are not making it pass, if it pass, it would go to the if it is reflecting back, it would go to the normal. But when the light is coming from the normal, it would go back. So what would happen, the light would not go at a normal, it would again reflect back. So this phenomena, when there is a critical angle where a specific less than a specific angle is required for the light to bend back in the same medium, when even it is not the parent object, the when the light comes back, this is called the critical angle of the reflection. So due to this, the light has formed. So, and as I have told you that light is made up of the several colors. So how could I prove this? There is a Newton disk. So what do the Newton do? He take the he take the disc and divide it into the 7 sectors. So he divided into the 7 sectors and color each with the colors of the rainbow. So colors of the rainbow are Vibgyor, which is violet, indigo, blue, green, yellow, orange, and red. So he painted these colors, and he rotate the disc so fast, and you will, if you also try to do that, you will see that a white color or the white, you will see the white thing in the white sheet is formed instead of these colors. So when the you mix all these different colors, you will see that a white color is formed. So this is how the huge rainbows in the sky are formed, and how these colors are formed. So friends, this was my part first of the part third of this video. Continue watching for the part fourth. Friends, I hope that you like this video as well as I do. And at the last, thanks for watching. Have a nice day.